Welcome back. So in this video for Chapter 7 in Industrial Organization, we're going to be talking mostly about the hoteling model, although we're going to start here with the multi-characteristic product differentiation. I will say it gets a little bit mathematical, but really the concepts are the important thing, and the math is actually not too difficult because we keep everything very linear. So basically what you'll say is that, when we have a store over here and a store over here, they're competing for the consumers all in the middle, and they're just going to sort of split the market based on that middle consumer. So that's really the most important thing right there. So with multi-characteristic product differentiation, what we're really looking at is whether the price of one good affects the price of another good, right? And so if it doesn't, then they're just not related goods. It doesn't have anything to do, and we don't have to worry. If it does, then we have to put the price of one good into the demand function for the other good. So this is basically the model that we had before. We took out the B here in front of Q1, and then we added this term here, minus dP2. And basically what that's saying is that the price for good 1 depends not only on its own demand, right, but also on the price of P2, and then we have the same thing over here. And we think of this as, D as sort of an index of product differentiation. If it's equal to 1, then they're perfect substitutes, right? And so you're basically just going to choose whichever one is lower. If it's equal to 0, then they are distinct. If D is negative, then that means they're complements, right? So the price of one will have the opposite effect on the price of the other than if they're substitutes. And we're going to come back to this type of model in later chapters when we think about just two firms that are competing and choosing their prices, right? And so that will be important. We're not going to go into the model too much here because we're going to use the hoteling model. And so for the hoteling model, it's really all about horizontal product differentiation. So what do we mean by horizontal product differentiation? Well, we mean there's some single characteristic, which we're going to call theta, that consumers disagree about. So some people like a little bit of theta, some people like a medium amount of theta, some people like a lot of theta, right? So you can think about it as color. You can think about it as, really anything that's sort of unidimensional for a product. And what we're going to sort of model is location, right? And so we're going to imagine that products differ along location, along like a main street, or sometimes it's like, you might think about ice cream stands on a beach. And so the farther you have to travel, the worse it is, right? But we can think of that as a metaphor, right? Because we can think of it as like, okay, well, I really want a red car, but if I can't get exactly red, then maybe I'm happy with something that I think is closer, right, to red. Or I really want a black car, and so maybe I'd be willing to take gray, but I really don't want green, or I really don't want white. So think of it not only as literal distance, but as figurative distance for different products. So we're actually going to come back to this circle model at the end, but you can think of this as basically, all right, there's a bunch of stores. So here's one store at 0. Here's another store at 1/4. Here's another store at 1/2. Here's another store at 3/4. And, they're all just differentiated based on location in this circle. And so, if you live here, right, then you're choosing basically between the second store and the third store, and you're going to go to the one that's closer to you. But if you're over here, right, you're choosing between the first store and the fourth store, and you're going to go to the one that's closer to you. And so we can think of this literally, right, when we're thinking about things like gas stations or grocery stores, but we can also think of it as a metaphor for individual tastes, right? It's like, I'm going to choose the product that's closest to my individual taste, even if it's not exactly what I wanted. But we're going to come back to the circle. We're going to start with just a straight line. And the straight line, I think, makes it a little bit easier to think about. And so basically we have a straight line street, right, between 0 and 1. We have two stores. The first store is at 0. The second store is at 1. So think of it as like a mile, right, of distance. And we have people who live all across that mile of street. And the two stores are selling the same thing. The only differentiation is location. And so the only question is, all right, well, how much do I have to travel in order to go to each of those stores, right? And so we've got this theta k, which is the location for this consumer right here. But there's another consumer right here. There's another consumer over here. There's another consumer over here, right? Because they're just uniformly distributed. And then the question is, all right, well, who's going to buy from which store? And it might be obvious, right? But we can actually use this fairly simple model where it probably is obvious, right? They're just going to split 50-50 and make it a little bit more complicated. We can think about what happens when the stores get to choose their location. So here's the way we're going to model this. We're going to say that the utility for buying brand I, so either 0 or 1, for consumer K is S. So S is some utility that you get from consuming the product minus the price that you have to pay, right? So either from firm 1 or 2, minus some transportation cost. And this idea of transportation cost is used a fair amount, right? It's used in this type of model where we can think of it as either literal transportation costs, right? Actually having to walk to the store, or we can think of it as figurative transportation costs of not getting exactly what you want. And so that is T, and then D is just the distance from location K to firm I, right? So the distance you have to travel down the street to either store. And so if we go back, right, the distance from the first store for consumer K is just theta K, right? That's just this distance here. And the distance from the second store is just 1 minus theta k, this distance here, dk2. And then that t parameter is just some cost function, right? Some cost. We also use that kind of model like in international trade where there's some cost of shipping the goods across the distances. We assume that the parameter S is the same because they're selling the same good, right? Because the only differentiation between these goods is their location along this one characteristic. But we do have to take into account price. Now, price is going to be an endogenous variable. And they will buy, the consumer will buy as long as this whole utility is positive. But if it's not positive, which we'll talk about in a little bit, then they won't buy. Right? They're better off just not buying at all. And we'll talk about how that might be used like in a voting model. All right. So here is the key graph, right? So here is the utility from buying from firm 1 on this vertical axis. Here is the utility from buying from firm 2 on this vertical axis. And then this is our street, right? Going from 0 to 1. So if you just live right at 0, then you don't have to pay any transportation costs. So you get S, and then you have to pay P1. So your utility is just S minus P1. Over here, if you live right at 1, right at the second store's location, then you get S, and then you have to pay P2. And then as you move away from those locations, right, the slope is minus T, which is the slope of, the transportation cost. And eventually these two lines cross at our median consumer, right, where they're completely indifferent, right? So up to this point, consumers prefer good 1, and then moving from this direction, consumers prefer good 2, and at this point, they're indifferent. So everybody to the right is going to go to the second store, and everybody to the left is going to go to the first store, and that's how many sales the firm will have. Now, note that these utilities are positive for everybody who buys, right? Everybody is getting at least this much utility from buying. And so we call this a covered market where everybody buys. But that might not be the case, right? If T is very high or S is low, then we'll have an uncovered market, which we'll talk about in a minute. Now, the key here is that as long as these products are the same and as long as the population is uniformly distributed and T is the same, then obviously the answer is that, they're going to split the market 50-50, right? So theta M will be 1/2. And firm 1 will get half the market, and firm 2 will get the other half of the market. And that's the standard finding in this sort of straightforward hoteling model. Now we can figure out the demand, right? So we assume, another assumption that we're having here, which is really a simplifying assumption, is that consumers have unit demand, so they either buy or they don't buy. And so the marginal consumer, right, that one who's right in the middle, is in difference between buying from firm 1 and firm 2. And so we can solve for that by just setting those two equal, and we get T minus P1 plus P2 over 2T. And then we can figure out the quantity, right? And so the quantity for firm 1 is T minus P1 plus P2 over 2T. And then it's just the opposite for firm 2 with the P's, so T plus P1 minus P2 over 2T. So basically, in order to solve any of these models, right, you just set the two equal, find that indifferent consumer, and then you can use that in order to find Q1 and Q2. And they'll split the market, and that's a common finding. Now, with an uncovered market, right, then because either T is really high, right, so the transportation cost is really high, or the utility of consuming the product is not very high, so S is low, then there will be some group in the middle here that doesn't buy. And so in this case, it's a fairly small group, right? It's between theta X and theta M, but they are basically not going to buy. And so, I mean, you can think of that like in terms of geographic location, right? There are some places, in the country, in the world, where there are not a lot of stores, and so people just don't buy from those stores, right? We can also think of this model has been used a lot for voting models, right? Where we have, candidates distributed along some dimension. And the utility of voting is, the closer the candidate is to your own position, you get more utility for voting. But the farther away they are, then the less utility you get in voting for them. And so, we've used this model to show why politicians might spread out during a primary, right? You're trying to get more towards the extreme and then come closer during the general election. But I think one of the interesting things that we can also use this model for is why people don't vote, right? And I think we see people both not voting, both because they might be in the middle, and so they don't like either extreme, but also we might get people voting because they're even more extreme than the main candidates, and so they don't actually get any utility there. And so I think that's an interesting use of this model. So one of the other ways that we can do this, right, is with what we call a circular city model. And here consumers are uniformly distributed around the city, right? And so, all firm 2 and firm 3 will compete for these consumers. Firm 1 and firm 2 will compete for these consumers, etc. And they still have a transportation cost. This is an interesting differentiation for the model because there's no endpoints, right? So there's nobody, that's really farther away from a store than anybody else, on those extremes. And so again, right, we can find that marginal consumer who's in difference between, say, good 1 and good 2, right? So consuming from good 1 gives you P1 plus T times XM. Consuming from good 2 gives you P2 plus T times 1 over N times XM. Set them equal. and find that xm, you get Tn minus P1 plus P2 over 2T, not that different than the hoteling model. And then the key thing is that each firm will get 2 times xm, right? Because, if xm is here, then firm 3 is getting all of these people, but then they're also getting on the other side. And so if we solve for that, the 2 just basically goes away, right? And so T over N minus Pi plus P over T. The key thing I think to notice is that demand is decreasing in your own price. So when you increase your price, your demand goes down, but it's increasing in the price of your competitor. And that's going to be an interesting thing when we start thinking more about different strategic interactions, right? Whereas if one firm raises their price, then it can be sometimes in the interest of the other firm to raise its price. And so we'll talk about models like that as well. All right, so we'll stop there for this video. It does get a little mathematical. Remember, just find the median consumer who gets the same utility from consuming from the store to the left and the store to the right. And then that distance is the demand that the firm will get. And so, with the straight line hoteling model, it's just, from one end to that middle point. And for the circle, it's, on both sides. So that's the only real difference there. In the next video, we'll talk about vertical product differentiation, which is all about quality rather than different tastes.